Welcome everyone. This is the Data Science DC Meetup on January 11th, 2022. Hope you are doing wonderfully. Today we'll be having Nicole Janeway Bills discuss the foundations of data strategy with us. So we're very excited to have her giving this talk. This is Data Science DC. We are part of Data Community DC. That's our nonprofit parent umbrella group that we and a number of other data science meetups fall under. Here's the logos of some of those groups. Encourage you to go to the datacommunitydc.org website and get involved and check out some of the other meetups that are going on in the space. And I should mention also that Nicole has her own meetup that she's running in conjunction with this meetup today, and I'll let her give information about that in just a minute here. And if you want to tweet about what's going on, we suggest you tweet at Data Community DC also on Twitter, and you can connect with us there. So we want to say thank you to our sponsors, Prefect, ATA, and our two title sponsors, and they help us keep the virtual lights on in our Zoom world here. So someday when we are back together again in person, these are the folks who will help provide the pizza and drinks. So thank you to both of them. So I'm Jeff, and you can get a hold of me here. Tommy is also with us today, and there's Tommy waving. And Chris is not with us today, but we are the folks who keep things organized here at Data Science DC. So if you want to reach out to any of us, please feel free to do so. Those are Twitter handles down there at the bottom, but you can also reach us via email at jeff@datacommunitydc.org or thomas@datacommunitydc.org, and we're happy to hear from you. We do have a code of conduct. I won't read it to you, but I will give you a moment to read it yourself. We want to make sure that everyone feels welcomed at Data Science DC events, and we assume that folks will be on best behavior, but sometimes there are folks who are bad actors, and if that happens, there are bad actions, and we will take appropriate actions. If you see anything that is concerning to you, please do reach out to Tommy and myself, either privately in chat or via email or any other way that you so feel. We also have a diversity statement here. We are a diverse group of folks, as you would see if we were all able to see each other right now. But we want to make sure that we have our diversity represented in our speakers and in the events that we put on. So we ask you to make sure that we hold us to this pledge of diversity here that we will try to uphold. And we encourage folks of all different types and backgrounds to get involved in our group. Couple upcoming events and announcements. We have another Data Science DC meetup coming up in February. We have metric stores versus feature stores on February 8th. So feel free to check that out. You can sign up at meetup.com/data-science-DC. We'll put that in the chat. We encourage you to subscribe to the YouTube channel for all of Data Community DC, where we post the videos when we have them. And join us on Slack. We have a community on Slack that is getting more active as time goes by, and you can be sure to check out all the events that are going on Slack. So we'll put all those links in the chat momentarily. If anyone else has announcements, please put them in the Zoom chat at this time, and we'll be sure to give them a shout out here. We'll give you 30 seconds to let us know what's going on. If you got a meetup that's coming up, or if you're looking for a job, or if you're hiring and want to try to let folks know, put that in the chat, please. We got lots of folks with us today. This is awesome. I'm not seeing that, at least in my chat, I'm not seeing things come in, so I'm gonna, oh, there's one. Varaf, if I'm saying that correctly, hiring a senior data scientist. Awesome. There's a job linking there. Tommy's got the links for subscribing and joining us on Slack. That's awesome. And I'll give you just a few more seconds here if anyone else has anything they'd like to share.
Everyone's feeling very self-actualized. They're very complete
It's
as
awesome.
is.
Cassandra Feng has a company's hiring data scientist. Awesome. All right, and there's joining us again. Thank you. All the info to stay in touch. All right, great. Thank you all. Well, excellent. With that, I'm going to turn things over to Nicole and let her take it away. So thank you so much for joining us, Nicole. Looking forward to the talk.
Awesome. Thanks so much, Jeff, for the intro. Okay, so I'm going to kick things off by sharing a couple of links of my own, along with a disclaimer. So 2 links, 1 disclaimer. First link is in the chat now. This is sort of your pre-read page. So I put this together so that you can follow along with the presentation, and also so that you can quiz yourself afterwards. So one of the things that scientists who study learning have found is, we don't really retain as much as we think we do. But we can dramatically increase our chances of understanding something over the long term if we use self-practice. So flashcards are really helpful for this, and this page has flashcards built in. Actually, I'm realizing it would be helpful to have a visual. Okay, so you should be able to see my screen now. This is the web page that I dropped in the chat, so you can see there are slides for each section. And then there's also like questions that you can use after the meetup to test yourself on your long-term retention of this content. And the Orbit app will actually, if you want to sign up with them, they'll then send you an email that leverages spaced repetition. So at the intervals that you see here, 5 days, 2 weeks, 1 month, and so on, they'll actually send you an email to make sure that you're actually still retaining these concepts. So if you're passionate about data strategy, this is a great way to lock in that knowledge for your future long-term leadership potential. Okay, so that's the first link. And then let me get back to the chat and I'll post the second link. Okay, hopefully this is okay. This is the feedback forum for the event. So just my portion of it, you guys can grade me and let me know how I'm doing. I aim to be data-driven in everything that I do, and that includes talks like this, so you can let me know how this event can be improved for the future. And then the disclaimer part. So I'm actually no longer working as a data scientist. I reskilled as a software engineer, and I'm starting as in a back-end role at Coinbase a week from today. And so hopefully the advice around data science and data strategy is, still valid. And as they say about data scientists, they never die. They just get broken down by age. And that's the first of many dad jokes that you'll hear in this presentation. So one of the great things about this format is I can't hear you guys booing me. So that's good. Okay, so let's get started. Okay, yep, foundations of data strategy. All right, and we're gonna go ahead and dive into some introductions. So Jeff, thankfully already pretty much covered this information. I was going to call out Data Community DC, Data Science DC, some other good organizations in the DC area. Women Who Code is super active, and they have a Python group that does some data science stuff. Another one, this is a podcast that I like. And then this is my Meetup, Data Strategy Professionals. And then the 2 courses that we offer along with the data strategy professionals. We can talk about that more as we get through this. Okay, this is me. As I mentioned, I used to work as a data scientist. I started my career as a strategy and operations consultant. And that was just, 10 projects, traveling all around the US. I realized the part of that I really loved was analytics. And so I did a boot camp and then went back into consulting as a data scientist. But I only did 6 months of work in natural language processing. And then the rest of my time was actually, so I did a year then following that of data strategy. So that was database implementation and like metrics and evaluation, kind of like initial program development. So yeah, it was super exciting, like really engaging stuff, mostly for federal clients, or well, entirely for federal clients in my like second career. So now I'm into the third software engineering adventure. Cool. Okay. If we get bored of talking about data strategy, we can always talk about travel, because that's something that I love and I really miss from the before times. Okay. So the objective of this presentation, so you guys are mostly data scientists, and a lot of this stuff is not going to be relevant to your day-to-day job. However, if you have the ambition to become a leader in technology, you should know the end-to-end data management processes. And this is important whether you're at a startup or a medium-sized business, an established business, a nonprofit organization, or if you're working in government. This is how you protect your customers and constituents, and how you protect your organization from failing to capitalize on its comparative advantage. So we will, chat more about what's entailed in end-to-end data management, and hopefully will increase your, your potential to become a data strategy leader. Okay, I like to joke that this is how data scientists see themselves in relation to the rest of their team. So we think we're the rainbow, and we kind of are, but there's a whole other spectrum outside of visible light that plays a role in, in the material world. So you have your data engineering, data ops team, and the DevSecOps team that help to, get the data ready for the machine learning pipelines on the one end of the spectrum, and then on the other end of the spectrum, productionize and continue to improve the models based on user feedback. So, data scientists may not have the full visibility of all the work that goes into getting data ready and then deployed. But here we're going to start changing that. Okay, so here's another view of kind of what we just looked at, slightly more complex. This is the Aiken data framework, or the Aiken pyramid. And as you know, if you've ever played Jenga before, any kind of pyramid or tower structure, it doesn't work very well if you start pulling pieces out of it. And so what I've seen in my work as a data strategist is a lot of organizations want to jump straight to the pinnacle here, data science. But that does not go so well if you don't have these other supporting functions that are represented in the pyramid. Okay, so if you need any further motivation for why this is an important area for you to consider, in the year 2020, there were 40 trillion gigabytes of information in our digital universe, which represents about a 3,000% increase in just the span of a decade. And a fun fact, that can also be represented as 40 zettabytes. So I don't know when else you get the opportunity to use the word or the prefix zetta, but this is an appropriate deployment of a term of that magnitude. It's no surprise to anyone that more and more data is created every day through our Internet of Things, our connected devices. We have, better quality data, that's more granular and just spans more aspects of our day-to-day lives. So all of our jobs are going to become increasingly important. And then the outcomes of this talk, and really good data management, is that it helps your organization leverage your company's or your organization's data as a strategic asset, and mitigate risks associated with poor quality data. And just a quote here. So Joe Pipard, who's the chief research scientist at MIT, he said that the very existence of an organization can be threatened by poor data quality. So I'm sure you can think about many ways in which that could play out. But I just wanted to bring it up to emphasize again, like how critically important it is for an organization to really put data management front and center. Okay, and the purpose of this slide is to remind me to take a breath and see if there are any questions in the chat. So this would be a good time to ask, if you have any questions about what's been raised so far or where we're going. Oh yeah, I like this note about what a zettabyte is as a measurement. And then this, by the way, is one of my favorite things about Zoom meetings. It's like the robustness of the chat. So if you guys, I just encourage you to post your thoughts and kind of, get a good second level of discussion going there. And I think that's a really cool aspect of digital meetings. Okay. So yay, congratulations emoji, because now we actually get to talk about the content of data strategy. Okay, and then this is a web page that I showed you at the beginning, where you can follow along and see the slides broken down by section. Okay, so the content from today's talk is drawn from the Data Management Body of Knowledge. It's blue because blue is calming. The book is 600 pages, and it spans the 14 chapters of each topic area within data management, plus 3 additional chapters on implementation. And then the organization that puts out this book, they also produce a certification. So I wrote an article about that, and it's on Medium. So if you want to look that up, you can find it by searching my name or, using your Google Foo. And I took this test in October of 2020. It's open book, open notes, which I love because it replicates real world conditions where when you encounter a problem, you can go to the reference material. So you don't have to do any rote memorization in order to prepare yourself to take the test. And it's just, paste the web, sorry. Let me go back one slide. So for people who want to follow along with the web page, yes, it's very similar to the PMP. It's the PMP, but for data management. And it's increasingly being recognized. So we were, sorry, I just repasted the feedback form, which is good. Please do fill that out. Let me grab the,
I got it there, Nicole. I put it right above that. Should be good.
Oh, yay. Thank you so much, Jeff.
Okay.
Cool. Okay. Yeah. So anyway, so I think it's valuable. I think it's actually just like a great learning tool because as I mentioned too, the purpose of quizzing ourselves is to deepen our knowledge. And that's actually a really effective tool. As kind of like nerve-wracking as test taking can be, that just like extra bit of stimulation, it does help to lock things into our brain. And so, if for no reason other than because this is an interesting space that like is worth knowing about, taking a test on it can help you to deepen that knowledge. But I do actually see the certificate more and more being asked for on data related jobs and just like recognized as a measure of quality in this field. All right. So here are the 14 topic areas. So this is the pyramid, but broken down. And it's like roughly organized in order of like importance, which is very hard to say, but this is actually the percentage. It's organized based on the percentage of this topic on the certified data management professional exam that I was talking about. Okay. But unfortunately, in today's talk, we do not have time to cover all 14 areas. So instead, I just picked 6. And, like Maslow's hierarchy of needs, we cannot attain data science actualization at the top of the pyramid without first achieving the other, the physiological and safety needs of data governance, data architecture, data quality, modeling, and data warehouse and BI, and master and reference data. So these foundational levels of the Aiken pyramid, that's what we're going to be talking about today. And here's the survey. I guess it would be kind of interesting to post in the chat now which of these topics you think is the most important for an organization, and then we can kind of think at the end if anyone's answers has changed after we've had some chance to talk about it more. So either post the number or post the, and there is no correct answer. Obviously all of these are important. Again, the pyramid, like you can't have a pyramid with a hole in it, or you can, but not for very long. Yeah, cool. Okay, so I'm seeing a lot of data quality, some for multiple, kind of bending the rules of the universe here. That's okay. All right, well, feel free to context matters, of course. It's a very naive question, I would say. Data literacy, not mentioned, but it is the title of the latest book from the current president of that organization, DAMA, that puts on the the certified data management professional. So he would like Monica's answer. Okay, all right, let's keep going. Can we just pause for questions? I'm gonna keep rolling through. All right, data governance. So this refers to the practices and processes to ensure formal management of data assets. So other improvements will unravel without a good data governance in place. Okay. So we're going to talk about some processes, and then we're going to talk about the organizational structure. And just a reminder, all these slides are available on that webpage, so you don't need to take notes, furiously. You should be able to have that to refer to. All right, so let's start by talking about the processes. So it's very important to begin a data governance effort with a conversation about the organization's mission statement and strategic aims. So that will drive the motivation to sustain data governance over the long haul. The team can then document this motivation in the data governance charter, which should include a clear vision of future state. So as we turn now to talking about the organizational structure that's required to support data governance, I just want to point out that data governance is a process and not a project. So there isn't a set end date. Therefore, it's important to maintain continuity by setting up roles and responsibilities that will outlast any single specific individual contributor. So you can't say, oh yeah, Bob's been here, Bob's in charge of data quality in, his, the Southeast manufacturing region. You need to say, okay, we need to take Bob's institutional knowledge and turn it into a role. And then that way it will outlast Bob. Okay. And here are some practical first steps before we get into kind of some examples of data governance. So first off, as I mentioned, you need to align data with strategic objectives. So data can be kind of ambiguous or amorphous for a outcomes-driven executive. So it's very important to link the benefits of high quality data and the risks of low quality data to the organization's mission and make that very clear to all the stakeholders involved. Second, set up an organizational structure around data governance. And third, conduct a data maturity assessment that includes conversations across the organization about data culture. This will help the data governance team get a better understanding for attitudes and behaviors around data. So in the data maturity assessment, you can ask questions like, is data freely shared across business units? Do data consumers have the skills and endpoints required to access the data they need on a day-to-day basis? Is data quality trusted? Unfortunately, I think that many organizations have a famous story of data that's not trusted in their organization. And so I think this is the time to root out those stories and document them and try to make sure that the organization never finds itself in that situation again, so that data trust can be rebuilt. And those sample questions will help guide the data governance process. Okay, so lots of text on this slide, sorry. I just wanted to lay out what a data governance charter could contain. This is not a firm rubric, but I think it's good if it starts with goals, it includes roles and responsibilities. If there's also a data inventory, so we talk about data sources at the organization, data inflow, so collection processes, data management, what happens to the organization while it's at the within the organization, data quality, which is part and parcel for good data management, data access / data security. So I just flew through that quickly because it's really actually data governance is the introduction, and then the sub bullets are the other stages of the Aiken pyramid, or the other chapters of the data management body of knowledge. So if I were to go through everything right now, it would take 600 pages. That's why it's such a heavy book. It makes for a great showcase for your sticky note collection though. So don't forget, it's an open book test. So reading it is studying, and sticky notes are too. Okay, there we go, advanced page. Oh no, that was backwards. Okay, cool. So this is a piece of sample data governance. At least it's the introduction to a data governance document, which you can find if you Google US Department of Defense data strategy. And I like this document. It begins with what in military terms is called a BLUF, which stands for bottom line up front. And that is just what they hope to get out of the data governance initiative, or they call it data strategy, but essentially it's the data governance charter. And what I also like about this page, this is the first page of their data governance document, they connect it to their mission statement. So they say data is a weapons system. How you couldn't be more explicit about saying, okay, our strategic advantage in data is to improve the weapons systems that we offer. Sorry, this is a very political example, but it is true that it's a lot easier to find these documents for public sector organizations. So agencies, US, very relevant for our DC crowd, but also universities will sometimes publish them. It's harder to just find on the internet, Johnson & Johnson's data strategy, but you can still draw from that no matter what size or industry your organization is. So, okay, anyway, back to the DoD example. So it talks about the vision, and then I like that it has also very specific areas for initial focus. So they say, okay, all joint domain operations, senior leader decision support, and business analytics. These are the 3 things that we're focused on up front. And I think this could be even better if they provide KPIs for each of these areas of measurement. So what does it look like to be successful in improving our data governance around supporting joint all domain operations and so on? just defining in a very measurable way what success looks like within this framework. And it's a longer document than just the front page that I've copied here. So that's worth taking a look at as you build out these documents for your organization. And then just to wrap us up, these are 2 quotes from the data management body of knowledge on the topic of data governance. So they say, the best data stewards are found, not made, and data governance is an ongoing process, not a project. So that's it for data governance. It requires a lot of time and energy, but it's foundational to improving the organization's data infrastructure. And that's why it's represented by this kind of like weird, like Batman ears type shape at the bottom of the Aiken pyramid. Okay, and I'm going to do one more section before I stop for questions. So we'll talk quickly about data quality. All right, so the data management body of knowledge recognizes 9 areas related, or 9 dimensions of data quality, but of course, there's no, like, this is not the end-all be-all framework. Like, it could be slightly different relative to the mission statement of your organization. But here are 9 plausible, measurable data quality dimensions that they outline. And according to the DMBOK, data should be fit for a purpose. It should meet the requirements of its authors, users, and administrators. In order to move forward with a data quality initiative, you should first set up a formal data quality reporting process. So in the book, The Lean Startup, Eric Ries talks about the importance of asking why 5 times in order to reach the root cause of a problem. And if you don't have time to ask why 5 times, then he suggests just asking the simple question of, how does the organization avoid this problem ever again in the future? So that's like really the core of the issue. Like, if something comes up, what can we do to prevent this? Like, how could we move earth and sky to make this never happen again? And then maybe backtracking, what is the version of that is actually feasible to implement? So anyway, so the 5 whys exercise, that comes from the Toyota manufacturing floor. So they really routinized like lean processes and initiated a manufacturing overhaul of efficiency and effectiveness. So that's still very relevant to, not just how we build things in manufacturing, but also how we build software and tools in the data space today. So second, so that was first. Second, you should consider data literacy training across the organization. So this is data owners as well as data consumers. And third, data quality issues might stem from a lack of quality metadata. And that's especially true in the era of data lakes. So it's possible that data is getting loaded into the storage system and then lost due to a lack of metadata tags. So efforts to create a data catalog could be useful in resolving this challenge. All right. Great. All right. So data quality, this was kind of a short section of review here. And I wanted to leave time for questions. So I see that there are several in the chat. I'm going to just go through chronologically. So Jeff asks, at what size company do you see that a formal data governance program should be created? Well, hopefully I answered this question a little bit, or teased it when I mentioned The Lean Startup by Eric Ries. This is really a wonderful book. I read it once a year, and I think it's relevant not just to people who are interested in like entrepreneurship, but every business has to innovate. And so there are startup-like processes that take place in every size business. And he really touches on that in the book. Like, he talks about innovation at big companies. So I guess the answer to the question is, it is relevant to startups because they should be super data driven in what customers they're targeting, answering all kinds of processes around their innovation and kind of like making a science of how they're rolling out their product and reaching the customer. So the Lean Startup is a great resource for that at the small business level, but really all the way through. And moving on down, what's an example of the 5 whys analysis? I mean, I don't want to throw any past clients under the bus, but like data quality issues that we had in my past job, where I was a public sector consultant, a lot of the times is like data gets siloed. And so one of the things that we were kind of asking ourselves, okay, so like, why doesn't this team want to share data outside of their like very specific team? Like, why don't they want to share it with other program offices? And so then the answer to that might be like, well, one time they did share it and then they were concerned that it wasn't used appropriately or it wasn't stored in a secure manner. And then the next question is, okay, like, why wasn't it stored appropriately? And then the answer is, okay, well, there weren't data governance processes that defined how this data should be stored in other organizations. So the receiving organization wasn't aware, and they just didn't have like the technical know-how to set up the correct storage system. And then, so this creates like a culture of mistrust around data very quickly. And that's kind of what I was talking about at the beginning of like, when you set up your data governance, you want to identify those emotional issues and kind of the history around data in the org. Anyway, so I think we've done like 2 whys there, and you can see like getting to 5 can be kind of a long exercise, but it could reveal even more problems. Like, well, why wasn't the data governance ever written? Well, maybe there was, but maybe it wasn't shared, or maybe that project was never completed, or process, not project. But okay, so hopefully that's a primer example of the 5 whys. We have 3 whys. Cool. And I see there's a link about Lincoln. It's like one of my favorite monuments, so I'll definitely am interested in checking out this example. I'll have to use this next time. Okay, awesome. And then it was also pointed out that there is a free data literacy course at SAS. So that's great. Definitely in favor of more free resources around these topics. Is a master's in information science business degree valued for this field? Yes, yes, it's valued. Are the certs required? No, certs are not required. So I honestly think that the biggest benefit of doing a certification is increasing your own confidence. Like, it's never no one's going to come to you and say like, oh, the reason that you didn't get this job is because you didn't take the top tier AWS machine learning certification. But when you do take that top tier certification and you ace it and you understand how the AWS ecosystem supports machine learning, then you feel empowered to apply for that job and take on the data science team lead role. And you walk into that interview with more confidence. And that's what a certification does, really. I don't think it's required. Okay, how do we measure data quality? So that, again, the 9 dimensions that were laid out on that slide. Also, I would point you to the DMBOK for more on those, like, what are those 9 dimensions? I'll flip back to it so you can see them. Okay. How is data governance regulated? Well, if you mean regulated from a governmental perspective, it's not. That's actually kind of a problem, like more broadly, that the FTC, the Regulatory Commission for the US, is not equipped to manage technology. In fact, like, of our senators and representatives, like less than 1/5 of them have any background in technology whatsoever. So they just are very ill prepared to deal with the challenges of data management regulation. And we're starting to see piecemeal regulation at the state level for data privacy, which is very important. But I think federal data strategy is really lagging in the US. And if you want to see an example of an interesting, there it was, and then it left. Oh, yeah, here. Okay, so this is a total sidebar, but Australia in December came out with a whole data strategy plan. So if you're kind of curious what that could look like, you can check it out. And I think I'm caught up on questions. Yeah, thanks. Awesome, Jeff. Are the 9 dimensions relevant to every organization? No. I mean, yes and no. Some will be more relevant depending on what your organization does. How do you choose which to focus on? I think that's part of the data governance conversation, is how to define your priorities when it comes to data quality. So with that, I'm going to jump into our next stage of the presentation, which is data architecture and modeling. And when I gave this presentation in the past, I just wanted to, I wanted to raise a point of potential confusion, which is that the term modeling or like model has multiple meanings. So I'm sure you've heard the joke like, oh, data scientists, we do it with models. That's like the most obvious kind of example of the data science modeling pun. But modeling even within data has multiple meanings. So there's modeling in the data architecture sense, which we'll look at here in a second. That's when you break down the business entities into diagrams and then you build that into tables. And then there's modeling that data scientists do, which could be more effectively referred to or more verbosely referred to as statistical modeling. Yeah, thank you. Tommy put it perfectly. So I just wanted to make that clear in case anybody who's learning about this field gets confused and they're like, wait, but I thought data scientists, they do modeling. And they do, but it's just statistical model is not the same as a data model or an entity model. Yeah. Okay. So now that we've made that disambiguation, data architecture and modeling represents the transformation of business needs into technical specifications. So architecture describes the current and future state of data infrastructure as kind of a blueprint. And then modeling shows us how data is connected and then how it will make its way into data tables. So we start in data modeling with the conceptual level, which represents business concepts and activities, and those are documented as entities and relationships. And then the logical data model captures more detailed requirements, so it just takes the conceptual model and it goes one step further. And it says, in this phase, we are building on the requirements and the existing documentation and adding associative entities. Finally, when you develop a physical data model, that outlines how data will be stored in the enterprise system. So this is everything from, like what are the storage systems or like what are the APIs that are called to link data across the enterprise. What sometimes happens, especially in big organizations, is that there's this tendency to want to skip the conceptual model and jump straight into the logical model. And this happens because the experts are at the table and they say, okay, we understand our business, like we don't need definitions. But there's actually a huge value, and I'm not just saying this as Nicole, I'm saying this representing what I've heard from other leaders in the data strategy space, saying that there's a huge value in actually starting with the conceptual model. And it forces everyone to align on definitions and avoid any kind of confusion before, hopefully avoid confusion before jumping into the deep dive models. So that conceptual data model is a huge aid to creating a common understanding of data relationships across the team. All right, and with that, let's talk a bit more about the data architecture phase. So you can get started here with an enterprise data model that provides a consistent view of data across the organization. An alternative view of that data is the data flow diagram, and that defines the requirements and the blueprint for storage and processing data across databases, applications, platforms, and networks. So here's what a data enterprise model looks like, kind of a flashback to the 90s. And this shows the entities for a sample airline. It's a holistic enterprise level and implementation independent conceptual model that provides a common and consistent view of data across the enterprise. So you can see there's like the nouns here and some very basic kind of relationships, but there's really nothing about like where this data is stored. It's at the conceptual level. Yes, similar to an enterprise resource diagram. All right, and then the data flow matrix. This is cool. It shows where data is created and then where it is read and updated. And it's representing the same information that you saw. Like it can represent business processes, and then here are the entities, and it shows you kind of how the data flows through the organization. So you can think of the creating as the like processing, and maybe the reading as the storage. Although I'm sure, I guess it depends really on like the organizational implementation of the of your physical data model. Cool. Yep. So you could add, you could even annotate this to note the storage system for each of these dots. All right, so moving on, let's talk about data modeling. And so the first step here is to select the scheme and notation that is most appropriate for your organization's efforts. And then gather the information, the entities, and the relationships that will be represented in the diagrams. And then finally, to make sure that throughout the process that the modelers are using organization-specific terminology as they're creating the models. So here we go. This is an example conceptual data model. So this shows things in the business and the relationships between them. And then we'll go one level further into detail. So here's a logical data model. So you could start to picture this being represented in a relational data table. And hopefully it's large enough that you can kind of see what's going on here. I'll leave it up on the screen for another second. This is, you see the entities, and the records are typed here, or the entities are typed with attributes and also relationships linking them across tables. Finally, the physical data model. So this is the actual structure of the database. And you see here the types, and you would also talk about the SQL implementation if you were putting this into a relational database. Okay, and this also, this would be just as relevant, although it would look slightly different if you were using another kind of data store like document database or graph database. And then, okay, so here's an example of the dimensional data modeling schema. So this is kind of what we looked at a minute ago, but I just wanted to call out how do you know what to put into a table? So that's like the dimensional modeling schema approach. So that entails breaking your information down into fact tables and dimension tables. So this here in the box, here in the center, it represents the fact table, which contains numerical values and foreign keys. And those foreign keys, they link to dimension tables. So dimensions are descriptive attributes that provide context to the fact table. Okay, so the fact, at least according to this approach, the dimensional modeling approach, the fact table does not have to be normalized. It is typically referred to as the star schema, and that is in contrast to like a snowflake schema where your data is normalized. That means like broken down basically as far as it can be, versus like this approach is a little bit more pragmatic, and it says just break it down as far as is valuable to the organization. I wish I could give an entire presentation on this, but we should continue. And you should post your questions. And also, you should read this book. Agile Data Warehouse Design is kind of a useful resource for this. They make it very like human readable. And then there's also a website by the same author that provides some templates. So you can look up model storming. I believe it's, I don't want to say modelstorming.com and get it wrong, but the author's name is Lawrence Core. I will post that here in the chat. And okay, so yes, he actually in the templates, like he can convert Excel tables into SQL statements. So that may be helpful if you're as you're learning Excel, or excuse me, as you're learning SQL, and moving your data out of like small data storage in Excel and into like a more robust storage system and a relational database. Okay. Yep. So okay. So we saw the fact table, and that just represented the quantitative information that we saw in our star schema slide, but in a table format. And then the dimension table, which is your qualitative data that is also here formatted as a table. Okay, super deep NoSQL. Love it. Yeah, I am learning Mongo now. I think that's like very popular recently. Document data store. So I'm not yet convinced that it's better, just that it's new. So anyway, okay, so that was data architecture and modeling. So please post your questions in the chat and I will do my best to answer them. Okay. So I'm just scrolling. All right. All right. So it looks like the first question is, what is data innovation? I don't know. That sounds fun. I think if you put data in front of something, like it turns it into like a, I don't know, it makes it seem more artful. So I almost feel like there should be some kind of like there could be like a data innovation. That sounds like an art exhibit that's coming soon to Hirshhorn. I don't know what that is. Oh yes, okay. This was a question about data quality. We already answered that one. Okay, Doug asks, what data analysts often encounter is data sets that were designed to be efficient in storing data and often are horribly inefficient for data retrieval. Often metadata gets thrown away in the storage operation. How do we address this? So I also do not know the answer to this question. I think it would save us a lot of pain. So if you do know the answer to this question, please tell us. Okay, data retrieval efficiency, says Smarty, is largely dependent on query efficiency. So that's a good point. Learn to write more effective SQL queries. use partitioning and indexing in your table design. Oh, that's fun. Data winnovation. I want that on a shirt. That's great. Is dimension and measure in Tableau. So Tableau, I think, I don't actually know like where they picked their terminology. It is true that measures in Tableau are quantitative and dimensions are qualitative. I think from what I remember of Tableau. I'm gonna keep scrolling. If the analysts don't understand storage, then the queries will be bad. Yes, that is true. Okay. Tommy and I are on the same page with the dad jokes. Yeah, I've got another one. Okay, so what is a data scientist presenter's least favorite drink? Booze. Yes, I really, really love Zoom because I just can't, you can't throw tomatoes at me. So I like that. Okay, I'm going to go back to the presentation, but please continue to post your questions into the slides and also your bad jokes. Okay, so we have 2 more areas to cover. The first of those areas is master and reference data management, and then we're going to wrap things up by talking about data warehousing and BI. So I honestly had not heard of master and reference data management when I started reading the DMBOK, but it's very simple. So I will hope to provide you with a more intuitive understanding of these concepts if you also were unfamiliar with them. Okay, so collectively, this field just refers to information about business entities and comparators. So master data is information about the business entities. It is collected and preserved as a source of truth and a resource that should span the entire organization. This reduces variation in how critical entities are defined and identified, and it allows for data to be shared across business functions and applications. It promotes standards of shared data models and shared integration patterns. So it is certainly an enabler of other fields, and it builds on that core understanding of business entities that we talked about building in the conceptual data modeling phase. Yep, and also metadata is super important. So yes, we know the DMBOK, so there's these 14 principles, and they really do like all knit together. Yes, it's encompassing everything. That's the tough part about data strategy, is you can't just like take a piece of it and say like, oh yeah, I'm good, we've got this corner, we've got this managed. If you don't have data security, it all falls apart. If you don't have good metadata, it all falls apart. So, okay, anyway, reference data. This refers to external data that should then be shared across the organization. It can sometimes be data that's from one organization and then shared to other organizations, but typically, like you can think of reference data as being like data that might be like purchased from an external vendor or that is shared freely through a government database. And it's used to provide context to the organization's functions and activities. So with master data management, the first step is to plan for storage in a system of record. So when you read the DMBOK, they talk about multiple styles of system of record. So it's not, there's a couple of different ways to approach this question of like, where should the source of truth live so that the different business units can most easily get at this data. So the next step is then to collect the entities and document the data that's going to go into the master data store. And finally, set up a process to monitor the accuracy on an ongoing basis, because we know this information will change over time. So if it gets corrupted, it's a really significant data quality problem, since it's supposed to represent those like core entities and be shared across the organization. Okay, so that's a quick chapter there. Oops, sorry. So yes, once again, these elements of data strategy, they serve to provide a common language, and they emphasize that data is a shared asset across the organization. All right, now to close this out here, we're on to data warehousing and BI. And this is probably a topic that's pretty familiar to most of us who've worked in data science. So a data warehouse is a data infrastructure environment that provides information to data consumers, especially data analysts and data scientists, as well as like particularly curious, business owners. And these individuals who work kind of at like further stages of the analytics pipeline, they go to the data warehouse to hopefully get cleaned data that they can then simply drop into the beginning of their pipelines. So whether or not that plays out in reality is an open question, but that's at least the goal of the data warehouse, is to have business ready data sets that they're already conformed to rules and they're stored in an easy to query format. And yeah, the data warehouse, it typically connects data across various source of truth operational data stores. The contents of a data warehouse have typically been restructured for speed and ease of querying. This serves to increase performance through partitioning, indexing, and decreased complexity of table joins, so that data that is typically used together is stored together in this like endpoint data storage system. Okay, so business intelligence. Somebody asked a question about Tableau earlier, so that's a good example. It refers to the tools to produce reports and dashboards that provide insight to business stakeholders. So Tableau is an example. Power BI is a less popular and performant example. Yes, and there's plenty of ways to do business intelligence just straight from Python. Okay, so I like this quote because it highlights the fact that business intelligence will often reveal the data quality issues that have persisted the longest. And that's because they're not obvious enough to get fixed. The stuff that is going to get fixed is the stuff that's obviously impeding the flow of money in a business. So like if your data quality problem is preventing the checkout button from working, then that ticket will get snapped up quickly. But with good business intelligence, it really kind of shows the sins that that might have persisted in the business for a long time. Yeah, and that doesn't. And so anyway, so these the ones that are shown through data analysis, they may still be impeding the organization's strategic objectives, and they're like chipping away from the optimization of the organization's comparative advantage. And so it's very important to have good business intelligence. It'll get those like high level and very busy corporate executives to care about the quality of the organization's data. So business intelligence can serve to, to cycle back to the beginning of this talk, like it can serve to motivate an effective data governance operation. And then that hopefully will improve the quality of data throughout the pipeline, so that then you end up with more performant, advanced analytics, like working with big data and conducting data science at the end. Okay, so just quickly, because I know we are over time, there are 3 steps to good data warehouse development. The first one is to design with the end in mind. The second one is to aggregate the data and to optimize it for the implementation of how this information will be used for business intelligence and data science. And then third, this is where the data literacy component comes in. So we really want to empower data users to find what they need in a self-service kind of way. So whether that's a Tableau dashboard that's hosted in a cloud, then they can just go straight to that page and do the CSV extract button, and then they have the data set that they need for their question. And they never had to send an email. They never had to bother the data science team. This is really the power of a good data warehouse and also good education. All right, and this is basically the same. So begin with the end in mind, prioritize the objectives, and seek feedback as you work on your dashboards. Start small, use the lean methodology. There's common themes. Okay, and that's it. So now we've tackled, these areas of the Aiken pyramid. So you should feel a little bit more equipped to become the chief data officer at your organization. And I'm going to scroll up now and see what questions have come through. So okay, so Mirel, I apologize if I'm not pronouncing your name properly, but she asks, is data governance encompassing everything? Data storage, data management, data modeling, quality, and operations. And so I did mention in the presentation, I do actually think the answer is yes. The more detailed you can make your data strategy, data governance, the better the implementation will be across all of the other stages of data strategy. Okay. Tommy says, I've never heard of a formal term, and let me know if I'm interpreting this comment correctly, but never heard the terms master and reference data, but sounds like has seen it in the organizational setting. So this kind of framework for thinking about these concepts is effective. Hopefully that's along the lines of the comment.
Yep, you got it.
Cool. Okay, is there a classification of data according to security level? That's a good question, and yes, and it will differ by organization. Yes, okay, so Bud shared the link to Peter Aiken's profile on LinkedIn, and I have never met him, but he seems very nice. I like his branding of an awesome thing. So I just clicked into his LinkedIn profile and it says bad data plus awesome thing equals still bad results. So I think he just based on what I've seen, he does a good job of making data strategy human readable. I did mention he just came out with a book called Data Literacy last year, and he's the current president of DAMA, the organization that that administers the Certified Data Management Professional exam. And it looks like he's based in Virginia. So he teaches at VCU in Richmond. Very cool. And okay, so Jeff asks, has anyone done the SQL murder mystery? And Monica posted her review. Doug says, medical provider facility are the ones that support claims because those are the ones that get audited. That's really sad. But yeah, the medical space is a huge opportunity for innovation in terms of data. There's so much data, and yeah, I could talk more about that, but okay. Cool. And then, yeah, design with the end in mind. Another book that I really like is The 7 Habits by Stephen Covey, and he uses that term. So it's a great book. I'm actually doing, this is my personal website, the Nicole Janeway one. And there's a post here. I'm doing a deep study of 4 books this year. Many people have more ambitious goals in terms of their reading, but I'm just doing four books. And The Lean Startup and 7 Habits are both on that like deep study list. So anyway, that was a digression, but yeah, I think, good advice is certainly relevant in this field as well. Isan, and again, hopefully that was close on your name pronunciation. He says, thank you for the great presentation. I think you briefly talked about this. Was there a specific reason you changed to software engineering from data science? Well, first let me say, I will answer that in a second, but let me see if there's any other questions that are that will be relevant to everyone before I talk more about myself. If you do have a data strategy question, you can email me. There is contact information on my, we can do the survey too. Wow, there's a lot of other slides in here. Okay, I was just gonna jump straight to this one to say, this is my website. I also have a Meetup, which goes by the same name, Data Strategy Professionals, where we can talk more about these data strategy topics. And then there's contact information here in the About page. So this is all a review of what we talked about. This is saying take the CDMP because there's a quality component of job posts that call for this exam. Okay, let's do the survey for folks who have stuck around. I know we're already 15 minutes over time. So thank you for everybody who's been able to stay. But I think this is kind of important and interesting. So this is the question that we looked at the beginning. And while people are putting in their answers now, 1 through 5, as to what is the most important. And also maybe if your topic changed, I think, or your selected most important topic, then let us know. I think that's interesting too. But just while people are thinking about this, to answer Ishan's question, I really enjoyed being a data scientist. I really loved working on natural language processing, and I wrote 35 Medium articles about data science. No joke, I actually published the 36th one earlier this week. And I liked it, but I wanted to also build front end, and I just wanted to do other things. I guess I get itchy feet, so that's really, it was more pull factors than push factors, because I did enjoy my time working as a consultant in data. Hopefully then that answers the question.
Can I ask a follow-up question?
Yeah.
So you just said that you wanted to do front end work, and that sort of pulled you away from data science. But didn't you say you just started at a back end position? So help me square that circle.
Yeah, exactly. So I took off work and I did an educational enrichment program, which may be of interest to folks in the group. It's called the Recurse Center. And in non-pandemic times, they're based out of Brooklyn, and they have a co-working space there. In pandemic times, though, you can do it from anywhere in the world. And I did that, and I spent the whole time doing front end with React, and also dabbling in React Native to build apps. So I built this website. We do a training course for the certified data management professional. And so this was just really fun. this is like an art project that people can actually use. And then I applied for a job that was a full stack engineer job. And it turns out that it's really more of a back-end role. So I've been frantically learning Go. If anyone is familiar with Go and wants to pair with me on it, I'm going through like the Go, like all the tutorial documents, and yeah. So they hired me knowing that I really had only ever done like, I mean, this website is only front end. there's no Node, there's no Express, there's no, they call it the MERN stack, MongoDB, Express, Node, or excuse me, Express, React, and Node. It's like a almost all JavaScript way to build a full stack app. And I just did the R, so I just did the React part. But anyway, so they hired me as a full stack engineer in an apprentice capacity. And then they told us after we'd already accepted that we needed to learn Go before our start dates. So it's awesome. Go is like, it's really powerful and exciting. And I've already talked way too much about it, but it's like all the best parts of C with like the ability to process data concurrently and do other cool things. So it's a really long answer. I hope that was helpful.
Would you say that a fair summary would be by accident, but you're open to growth in new areas? Yeah,
totally. I was like, I mean, I'm gonna have to conquer backend, so I might as well do it with like the best. It is like the most up-to-date, strongest backend kind of language. So yeah, I'm definitely excited about learning really fast. And I start in a week. Okay, another question. Any advice for data analysts / scientists who don't see the big picture? Do you mean like, sorry, while I answer this, I'm also gonna fix my computer, which is the charger's come unplugged. So I guess I think it's a good question, but I don't think I have the full context on like what kind of advice, what is the objective for the person who asked that? Around data governance. Okay. So if you're a data analyst and this presentation really excited you, then that's awesome. And I definitely think that, you know, you can have a great career and just do data science, or you can kind of like take more of a manager approach as you grow your career. So actually, let me flip back to this. Okay, so this is a slide that shows, it talks about the CDMP. This is a little out of date. This like numerical survey came from when the CDMP was first introduced. So the numbers have improved. But anyway, so it just shows that the positions that are associated with data strategy are leadership, architecture, and management kind of roles. So to go back, do you have any advice for somebody who is working as an analyst, but is interested in data governance and data quality? And I guess it's very situational, like it depends on how this runs at your organization. Because sometimes there already are these like, wait, there's a better way. Let me scroll. But sometimes there already are like the data governance, these people are already in place, like there are already these organizations, and sometimes there aren't. So maybe this is something that you can start like as an extracurricular at your organization. Like maybe you need to be the one that implements the where do we have it? The like 5 whys, the data quality issues reporting process. So maybe this is just like a Google form or a Microsoft form that you implement and you encourage people to use to report data quality issues. You know, if your leadership is supportive of that, then it could be a really great way to get started and start fixing these problems before they get into your data pipeline. So that's what I recommend, is just kind of starting those conversations and learning about what's in place at your organization. Okay. In what use case will you use Go instead of Python? So Go can be used for everything. You can do like web development with Go. Python is powerful for the scientific computing packages. So there's really great support for all the statistical modeling in Python. You can use Go for machine learning though. It just doesn't have all the same ease and like the Hugging Face, you know, built in NLP models and whatnot. So I mean, they're very different. I guess as data scientists, like you don't feel compelled to like go out and learn Go right away. Go is really effective for backends and for distributed systems. So like databases that are talking to each other and they need to reach eventual consistency, like Go is very powerful for that because it's blazing fast. I mean, by comparison, like Python is really slow. And Python will also like let you screw yourself over in ways that, because it's not formally typed, in ways that Go, because it is formally typed, it will not. But anyway, yeah, for data science, you can stick with Python. It's like perfectly acceptable and it's a great way to communicate with other data scientists. Hopefully that answers the question. Okay. Yeah, if you want to learn a compiled language for data science, I have heard that Julia is the future. There's actually a really interesting talk, and I can try to find it really quickly. Debate. I think it was sponsored by the TWIML podcast. Yeah, I'll post this in the chat. But anyway, they have experts from a variety of languages talking about machine learning in their language, which is hilarious. There's a guy doing like machine learning in JavaScript, which is, I don't know, I just like that kind of blew my mind that someone would try that. So I'm putting that in the chat now. When you were using Go, you were the full stack dev. Well, I just have run a couple of Go programs. I would say I'm using Go yet. So that's all. In data science, Python, yeah, Python is definitely the current dominant one, but I think, yeah, Julia might, I don't know. I don't want to like say, oh, it's definitely gonna take precedence over Go or over Python, but okay. Cool. Well, yeah, just once again, I'm just really grateful to the folks in the chat for being so active and for asking such great questions throughout. If you stuck around this long, I apologize for my dad jokes, and it has been a lot of fun. So yeah, I don't know, Jeff, if you have anything else that you want to say to wrap things up.
Just want to say thank you. I really appreciate your time and the dad jokes. We're all dad joke fans here. So yeah, it was great. Thank you everyone who participated and attended, and we hope to see you all in February. So enjoy your Tuesday night, y'all, and take care. Okay. Thanks.
Yeah, thank you so much. Bye. Have a great night.
Bye.